Hi all. So finally we are at the OOPS class, object-oriented programming. So where we'll be learning about class and objects. Okay. By default in Java, whenever we are writing code, we are always writing in form of class. Okay. Till now we are not aware, but if we could just observe in line 3, what is happening that public class OOPS. What is this OOPS? This is nothing but the file name. Okay, for us right now. And if you see, there is always mentioned as class, right? So that is what we are going to learn. What is class, what is its importance and all. But before going to that step, let's learn one more thing, that is access modifiers, which I had mentioned in previous class. We'll be learning further. So here, the public itself is an access modifier. Now, what is access modifier? What are its types? To understand that, let me create few variables. So the first variable would be public. Let's say public int num1 equal to 10. Okay, let's say 100. Then similarly, we have another variable, but its access modifier is private. Let's say it is private. Okay, and let's say let's change the number as num2 and make it 10. And let's say we have one more. And for this, we are not going to mention anything. So by default, it can be referred as default itself. And this is known as number 3. And let's make it 1. Cool. So what we have 3 variables and they all have a different access modifier. Now, how to understand what is the importance of public? For that, I'm just opening my file explorer. Okay, here you can see now presently I'm in which OOPS file, and it is under the access modifier package, right? In fact, if I create a new file here, let's say the file name is test1.java. Okay, we have test1 Java, and in this, if I want to access this variable, so how would I access it? For that, first of all, let me create a function. So inside class, I have a main function or a method, I can say. And in this, I'll create an instance of this OOPS. That is, I'll try to import it here. So OOPS data equal to new OOPS. Cool. So what I did is I just created an instance, or you can refer it as an object of class OOPS. Okay, what is this new? We'll come to that later. First, let's assume that object is created. For now, what is the benefit of this object? Like we can just access all the properties that is inside this OOPS. So if you see, we can access num1 and num3. So num1, hold. In fact, let me do it south. And let me put this data.num1 control X in this. Yeah. And let me duplicate it. And what we had num1, num2, similarly num. Okay. If you see for num1 and num3, there is no error. It's working fine. But for num2, there is an error. Why? Because if we see in our OOPS class, in our main file, what we had is num2 is a private. What does that mean? That this num2 can be accessed only by this class. That is class OOPS. Let me split this screen and let's go back here. Okay, so for that reason, we can't call it here. So let me comment it. Good. And if you see, there is no error now. And if I try to run it, be able to see the 100 and 1. 100 is nothing but num1, which is public. And this is a default. Clear? Got the point? So what we understand by this, so whenever we say private for, let's say, any function or a variable, that will be available in that class itself. Now it is available only in this class, okay, num2, and not in any other folder. Clear? We got that difference. Now then what is the difference between this public int as well as int num3? Because here we are able to access both. So to get the understanding of this, now let me create one more file. And this file I am creating outside this package, that is outside this folder. Okay. In this folder, I have OOPS and test1 Java. I'm creating outside this. So let's say I'll create here. I'll name it as outside.java. And always make sure that your file name starts with capital letter. It's a good convention to write. Okay, cool. So here, if we see, we have outside Java. Let me split this screen also. Okay, fine. Let me bring back this oops here. Okay. So now here, what I'll do is I'll again create my main function here, and I'll try to copy all this what I have written. Control C and Control V. Okay, let me uncomment this. So if you see here, num2, even here it is not accessible, and this we knew why, because it is a private. But here, if you see, num3 is also not accessible. Why? Because when we declare it in the form of int num3 and we do not mention any public or anything, then this variable, or if you create any function and if you directly say void function name and not specified the public, then these types of functions or variables will be available only inside this package. Like for example, the access modifier is a package, and inside this, if there are multiple files, it can be accessed. But if you try to access it outside this package, so if, for example, this is outside this folder, right? Now it won't be accessible. Okay. So I hope you are clear with this. So only thing that will be accessible here is data.num. Why? Because it is a public. So where it is? Okay, it's here. So if you see, it's a public. Okay, this is our main folder. This was our outside. So here data.num1 is active, and this was our inside the access modifier file. And if I try to run it, I'll be still able to get a 100 as an output. Clear? Okay, cool. So I hope you have understood this till here. So the importance of access modifiers, there are 3 types: public, int, not int, like public, private, and a default one, which we need not mention anything like public or private. And this will just help you to access the variables in particular files. So that's why the name is given as access modifier. Great. Okay, good. Now, the next thing will be to jump to class and object. So let's explore class and object now. So for that, let's go to the mind map that I have created. Okay. And if you see here in class, okay, before understanding the 4 pillars and all, why actually we require class and object. So to understand that, let me just write the, so our question is, why we require class? Like, what is its importance? So you can say like, if you are creating a robot, let's say you are creating a robot and you are declaring all its functions like how to walk and drive, everything. So for that, you are saying class robot. Okay, that's good, but it still didn't provide us any meaning. What happens in this class robot is that whenever you want to create now multiple robots, like robot 1, robot 2, robot 3, you need not write the code again for this. What you can do is you can simply create the new instance of this class robot. So whatever functions, the variables, the data, whatever you write here, that will be accessed by this R1. Okay. That will be accessed by this R1 robot. That is the new instance of the robot. So what is this? This is the object. Okay, we can create multiple objects and we have one class. Cool. That's the one thing that we understood. What does it helps us to do? That we can create multiple instances and we need not write the functions, data, everything. We can write it just once and we can just duplicate it multiple times. Okay, cool. So is this the only work of class, like creating the object, like helping to do it? No, there is one more important point, that is with the OOPS concept, we can write our code in a much systematic way. Okay, what do I mean by systematic way? For example, now the same robot, let's say now you have one more robot. For example, this is the first robot is for human replication. So robot human. And the second one is dog. Let's say robot dog. Yeah. Now, what you can do is these all functions, you can write it in a particular file. Okay, let's say walk. So this is a walk present here. Even dogs walk, right? A robot dog. Robot dog. Okay. Now, what happens if you do it separately like this? So if you see, when you have separately doing a class here, you are in fact creating all the functions and variables for this robot human. So whenever you are creating any object, you are referring all the documents, like all the details in one place itself. It is not jumbled. In case if this class was not there, then this walk and this walk will be mixed up, right? We are not able to separate it, right? So what does class do? It also separates it and keeps it in a systematic way, right? That can be one importance. So, okay. So I hope you are clear with this. If you are not, let me give a final example, which will help you to understand. Like in future classes, what we'll be doing is we'll be learning swing, SWING, swing. What is swing? Swing is a package or a library, we can say, which will help us to develop the desktop application, like GUI application, graphical user interface, like calculator, then paint application, anything like that. Okay, cool. Then how is it related to class? Because here we have a class swing, which is already written by some person. Let's say he has already written. Okay. And what we do is, let's say we want to create our own paint application. So let's say we have done paint application. Let me write it properly. Okay, so let's say we want to create our own paint application. So let me write PA. And when we want to create, now it doesn't make sense to again start from bottom and create the layout and this minus symbol, this square bracket plus symbol, and right. It doesn't make sense to start coding from it. This everything is already written in this class swing. So if you just create an instance of this, and if you say like this is belonging to swing, okay, if it is belonging to swing. So for this, what is our paint application? We by default have our window, which is having minus square bracket plus. Okay. So from here on, we have to develop with the help of whatever function methods we have. Let's say it has a function named as button. So with this function, we can create a button here. Okay, if it has a checkbox, then we can create a checkbox like that. Yeah. So here, if you have understood what happens, so we are easily able to create our own applications or anything on top of this class. Okay, instead, we are just creating an object. Okay, we are creating an object and modifying the existing data in this. Clear? So I hope you have understood what is class and objects. Now, once we have understood that, let's try to explore the 4 pillars of class and objects. Not class and objects, in fact, only class. So the first one is inheritance. What's inheritance? Like, let's say you have 2 classes, okay? Class 1 and class 2. Class 1 and class 2. As example, what we discussed earlier, we said robot human and we had a robot dog. And each had a common a common function like walk, right? Then it didn't make much sense to write it here. Why? Because they are performing the same action. They are going to walk, right? Then in that case, what you can do is you can inherit from this class 1 to class 2. So whatever the data is present here, that data can be also available with this class, that is robot dog. We'll try to do few examples, then it will be a bit clear. So let's try to see what are its types. So in inheritance, we have again single inheritance, multiple inheritance, multi-level, hierarchical, and all those. And these are not complex. You just need to remember one, and they are simply same. They simply gave different names. So for this, I remember it in a simple, easy manner. They're saying dad and son. So our first class is dad, and second class would be son, and we'll inherit all the properties from dad. So that is single inheritance. Then the second one is multiple inheritance. Like let's say now you have a class dad and a class mom, which are 2 separate classes, and you want to inherit to son. So for example, if it is class dad, and here we have class mom, these 2 are not inheriting, but when we create class son, we want to inherit from dad as well as mom. In other languages, it is directly possible, like in Python, but here it's not directly possible. So we use a keyword like interface here, which will help us to achieve this. Okay, you need not worry that much. So just say like if you want to inherit, like interface will help us to do that. Okay, so we have multi-level then. What is multi-level? So here the multi-level is nothing but one after the other. So now class dad will be there. Then that will inherit from class son. Then son will inherit class grandson. Okay, so for class grandson, we'll have all the properties of dad as well as son, whereas son will be having only the properties of this dad, and dad doesn't has any inheritance about. So this is pure content, I can say. Yeah. Okay. So it's not that only this data here, you can do additional data are also available with this. So whatever the details of class dad as well as class son plus its own definition, its own variables, its own function can be available. Yeah. So I hope that's clear. And hierarchical inheritance is okay, a single class dad, and this is being inherited by two separate classes which are like independent from each other. So class son1 and this is class son2. Clear? Okay. So I hope this is clear. And hybrid is nothing but a mixture of this. Like we can mix this and this, this and this. So something mixture of this can be considered as hybrid inheritance. You need not worry of this too much. Just try to understand like how it's inheriting for one. For rest, it will be almost same. Yeah. So let's practically do it once. So let's go back to this and our oops Java file. Let's go here. Okay. So this is a public class oops. Inside this, we had few variables. Let's not disturb this and let's create a new class outside of this class oops. And for this, I'm saying class dad. Yeah. Okay. One thing to notice that here I didn't mention public, private, or anything. I directly mentioned class dad. That is because a single file can have only a single public class. Okay, there can't be a double public class. For example, if I say public here, you see there will be a error. Okay, so to avoid this error, we have to remove this class. Okay, if you ask me why, because if you have focused on our first class, that is when we are discussing how the code, this code is converted into the binary code. Okay, when we discussed that time we understood that this file is presently in the .java extension and this will be converting into .class. So when this will be converting, we just require one single class to be converted. Now it will be converted like, let's say oops.class. If you have multiple classes, then it will be confused, like which one to export from this. Like when you will be inheriting from here, like when you will try to access it, test1.java, this file there, it will be confused. So we have only one class, okay, as a public. Clear? Okay, so I hope that is clear. Now class dad, inside this, let's create few constructor. So for constructor, we directly write the class name itself, and then I say curly brackets, round brackets, and a curly bracket. Clear? Okay, now what is constructor? Constructor is a place where you define or declare your variables for that particular class. For example, let's say dad, I'll say muscle, a random thing which I took, muscle. So for this, I'm creating a variable, let's say, and here I'm using the keyword this dot muscle equal to whatever muscle I'm getting as the input. So as an argument, let me change a few things here. Let me give a mus only so that you need not confuse with both. Okay, good. So I have done this, but there is a slight issue saying that this mus is not yet defined. So I'll simply declare here as, let's say, int mus. or I can say arms. That will make much sense. Arms. Control C. Error here is that I have to mention the type of data that I am receiving. So this is int muscle. Okay, and this dot arms is muscle. So whenever you create any object of this stat, so for that particular object, you can refer it by saying arms. Clear? So if this is not clear, let me create a main method here. Okay, let me enter and let me type main. And inside this, let me create a object of that. So that object one equal to new that curly brackets and semicolon. And if you see, there is a slight error here because we have not yet entered the muscle or biceps. You can say something like that. Muscle, let's say here I'm giving us 10 points. Clear? So for this object one, the muscle that is entered is 10 and that is stored in arms. Okay. Similarly, if I create second object, let me say this is object 2. And for this, if I give it as 9, for this person, object 2, the muscle that is stored in arms. How to verify it? So let's do here south obj1 dot arms. Here, let me duplicate it and bring it down. And let me change it to object 2 dot arms. And let's run it and check. If you see, 10 and 9 are displayed. So what do we understand by this? So that, what is that here? It's a constructor. Okay, so whenever a function name is written as it is a class name. So if you see, if the class name is that, and the same thing we have written here, and we did not mention any return type here like void, int, and all, those are need not be mentioned, and it shouldn't be mentioned first of all. Okay, then this is known as constructor, and in constructor what we do, we pass few arguments which will help us to declare the variables for that class. Why do we need to declare the variables? Because whenever we create an object, so for this particular object, there are predefined variables like arms, and to store value in that, we pass like this arguments. Clear? Okay, cool. So we are done with here. So we understood constructors. So once that is done, now let's create few functions. Let's say, what I'll say, void, that is the return type. And let's say hit, random things. Okay, there's nothing. Hit, south. Let's print hits with belt. Let me know if your dad hits with belt in comments. Cool. So if you see, this function is not taking any arguments or anything. It is directly displaying hits with belt. Okay, when we call this function, for example, if I do obj object 1 dot hits, yeah. So the same thing I can do it with object 2 also. So let me just change it to object 2 and take it down. Good. So both should result with hits with belt. So let's see if it works fine. Let me pull this up. Let's run once again. So if you see, 10 is displayed as arms size or arms point, and hits with belt and hits with. Clear? So we created our first class. Now what we are actually going to discuss, like here, single inheritance. We are trying to see how it will be inherited by son. So let's create a class son. Okay, so that's it. We created a class son, but this we wanted to extend it from class dad, so that whatever we have defined this should be also present in son. So for that, what we'll do is extends dad. Okay, and then a curly bracket. Okay, so to create the class son, we'll say class son, and what we want to inherit the details from class dad. Okay, whatever we have defined here, that should be inherited. So for that, I say class son extends what does it extends from dad? Okay, so curly brackets and there is a slight error here. That is nothing but it is saying we have not yet created the constructor. So let's create the constructor. Okay, if you see son int muscle super muscle. Now what is this super keyword? Super function is nothing but it will help us to inherit all the constructors from parent class. Okay, so dad is the parent class, so whatever has been written here, that is inherited here. Clear? Okay, and if you want, you can define your own arguments also. So for example, here I'll say int packs, and here I can declare later this dot pack equal to packs. Okay, now why there is an error? Because we have not yet defined or declared pack. So let's declare it. So int pack whole. Okay, that's it. Now if we create a instance of it, let's try to create the instance here. Let's say son, and I'm going to say object 3 equal to new instance of son. And if you see, there are now two muscles and packs. For this, it was just muscles. So let's say muscles is 7 and packs is 6. Clear? Okay. And if you do south, what should we do? Let's say object dot object 3 dot, let's say pack. It will give us that, and let's see if the hit function is available with this. So object 3 dot hit. Let's run and see. Okay, if you see here 10, 9, 6. What is 6? 6 is nothing but packs that we displayed in 14th line. Okay, that we have written here. And object 3 dot hit. If you see, there is no hit defined here. Did we define any hit? No, there is no method present as hit, but still it was able to give us the same answer, that is hits with 12. That is because we had written this statement here, that is extends dad. Clear? Okay, so I hope you are clear till here and there is no confusion. So this is how we are inheriting. Now, if it was hierarchical inheritance, then it could be simply dad, son, grandson. Okay. So the same thing keeps on repeating for all of this. Okay, so as we do some project, we'll be doing it in detail. Time being, you need not worry that much. Let's only do this multiple inheritance because there is something new here, that is interface. So let's quickly do that. Yeah, I have cleared my screen and let's create a interface. So if you see now, I'm creating an interface and not a class. So I say interface that. And I'll just define I'll just name the function. So let's say the function name is void hit. And that's it. Let's say this much. And yes. So this is the first interface of that. And let's create one more interface for more. Okay, what I have done is I have created two interfaces. And from this, I can inherit in the son class. So for that, what I have to say, let's say the class is son. And this will use implement and not as extend as we did previously. Implements, what it implements, that, comma, mom. Clear? And I'll just change this function to, let's say, something like this, so that we can refer it. Let's do it, Papa. Okay, something like that. And now, this son can access both of this. Okay, for that, first of all, I have to override it. So I have to define this function. So here I'll write override. What it should override? The Papa function. So that can be void south high. Okay. Clear? So here it's asking for this Okay, so just make sure you need to add public. And after that, let me duplicate it. And the same thing for it will be normal. Let's say this is from mom class, mom interface. Okay. Control C, Control V, that. Clear? So this is how we are able to inherit from two different interface simultaneously, okay, with the help of implements. That is possible only if we use interface. Clear? And if you want to check it, we have to simply say sun object 1 equal to, let's say, new instance of sun. And now the object 1 can access dot, if we say we can access mama as well as object 1 dot click, and if we run it, it will work fine. Okay, clear? So I hope you are clear now, and we are able to inherit from different interfaces, from different class itself we can consider. Okay, so this is how it's done. And the rest, that is multi-level inheritance and hierarchical inheritance, these are all same. Here how we have used extends, right? The same thing you have to use here. Okay. So after that, let's move to our second pillar, that is polymorphism. In polymorphism, you can consider that it's a function of a function name that is same in various classes. Okay. So based on which class it is, a particular function is being called. Okay. You can imagine something like that. So for example, here we have two methods now to create it like that. The first one is overriding and the second one would be overloading. The overriding is used when there are different classes, whereas overloading is used when it is a single class. So let's try to explore it. So for overriding, let me again create two classes quickly. So let's say class that. And the main purpose of polymorphism is to have the same name itself. So void, let's say hit again, hit. Okay, south. And here I'll give it as something well. Clear? And let's have a different class that is mom. And here I am simply going to change it to, let's say, broomstick. Okay, cool. So if you see now we have two different functions. Okay, now if we want to override, so polymorphism is the one like a single class, and whenever we call the function based on the class, it should be able to call. So for example, I'll create a main class. So class parent. And inside this, I'll say our main hit function is declared. So similar to interface what we had done initially. So void hit. And here I'll simply say south from parent class. Okay, so if you have some condition like this, now this all three are separate. So let's make the dad dependent on extend parents. So I'll say extends what? Parent class. Okay, and the same thing will happen with the mom class. Okay, now how to make sure when we call the dad class, this function is executed and not this function. Okay, so that's where we have to write here override at override. Okay, and the same thing we have to follow it for the mom class at override. Clear? And now if I create an object, so let's say our object will be what? A parent object 1 equal to, now if you see, I'll be calling the dad class dad. So let's say new dad parenthesis colon. If you see the main while creating the variable, we had mentioned parent, but by initializing here, I had mentioned that, and it will work fine because the dad is nothing but it is extending the parent class itself, right? It has inherited. Okay. And let's do the same thing with the mom class too. So here I have mom. Let's change it to object two. And once we have this, now if we simply say obj1 dot hit, whereas same thing with obj2 dot hit, its respective functions will be called. So let's run it. Yeah, so we got belt as well as we got broomstick. How is it, like what's the main importance of this? So you can define a common function like hit and all, and based on whichever class it is, its respective work will be called. Okay. So if you see now we have our main parent class, and in this we had a hit function. Then the dad and mom also had, but we did override, and through that we are able to access the correct hit function. And if you see, these are all different classes, and this is being called at the runtime, like this function, whatever is this function, right? This will be decided at the runtime itself. That's what I have mentioned here. That different class method is selected at runtime. What if it is method overloading? It's obviously used when it is a single class. So let's say when this is a single class parent, from parent class, I'll just Control C. I'll make sure here there is one more void hit. Okay. And now if you see, it's giving us an error. Let's come up because they both are same. Okay. But to differentiate for method overloading, what we have to do is we have to give some arguments. So they are different. So string items from parent class plus items, I can say. I'm just trying to show you like the difference, the technical usage, the real life usage I am not implementing here. I'm just trying to show how they are different and similar. So if you see now void hit, even this is the same function name as this, but now the only difference is that I'm taking an argument here. Therefore, whenever I create a parent object, so here I'll just rename it as parent as well as this parent. Now, this hit function is always going to call the second one and not the first one. Why? Because the first one requires an argument. So let's pass an argument. Let's say hi. Or let's say hi itself, and let's run it. Okay, if you see the first one, it said from parent class hi, whereas the second function called this. Clear? How did it understood? It understood with the help of arguments what we are passing. And if you see like when this will be compiled, then it's like at that moment itself, the Java will understand which to call based on the conditions that you are passing. And that's what I have mentioned here. Method is selected at compile time itself, whereas in the method overriding, it is selected at runtime. Clear? So what is polymorphism? Polymorphism, you can consider it as a same function name used in different classes. Okay, based on the class, its particular work will be called. Clear? Once we start doing some projects, you will get to know its importance and all. Okay. So these are the two things. Now let's move to the next one, encapsulation. So encapsulation is used when you want to hide some data from your class. Okay, let's first see what are these. So mainly there are data hiding and access modifiers. Access modifiers we had discussed in the initial class itself. So this is how you can hide or display the variable or your functions and all. And data hiding is once you do private, then we can use a separate function as getter and setter methods to showcase or hide your data. So let's try to do this encapsulation part. So let me create a class bank. Okay, and create two variables. Let's say the first variable, I'll make it as private because this is account ID something you can say. And initially I'll set it to 1111, something like that by default. And I have to also declare the data type. So in this, okay, cool. Then what I'll do is I'll initiate a public, I'll say string data type, and it should be like user ID, user ID. And for this, what I'll do is equal to ABCD. Yeah. So if you see now, I have two variables. The one is public and one is private. So the thing here is that we have encapsulated this account ID. That means this account ID cannot be accessed outside of this class. For example, if I create a instance of this class, so let's say bank Swiss equal to new instance of bank, new instance of bank. Okay. And if I try to access, so let's do south and let's say Swiss dot user ID. So for user ID, there is no issue. Let's see for account ID if we get anything. Account ID. Okay, so if we see for account ID, it is highlighting as an error. Why? Because this field bank.account ID is not visible. Clear? Because this is a sensitive information. So when these are like sensitive information, and we can see here, for those we have to set a special function as getter and setter. So get will get the data, whereas set will set the data. Why we do like that? To just have some security check. So let's have a dummy check here. So let's say here I'll do void and get a data, I'll say something like that. And for getting the data, I have to need the account ID, right? What he will say. So ACC ID. This will be again int. So this is the new ID that he wants to change. And I'll change it only once if we pass the correct password. Okay, so this is something like condition I'll put here. The condition that we can't put in user ID. User ID, anyone can change. How? Let's try to change it here for first. Let's change the user ID and see. So here I can say Swiss.user ID, which is this, Control C, Control V equal to what I'll say. I'll change it to mechaniccoder. Mechaniccoder. Okay. Swiss.user ID equal to mechaniccoder. Let me put a colon. And then what I'll do is I'll duplicate this and call it down. And if I check it now, initially it will print as ABCD. For this, it will print as ABCD. But when I check for this, it will be printing as mechaniccoder. Yeah, it will print as mechaniccoder. Okay, so I hope you are clear with this. But the same thing can't be done with this with Swiss.user ID, because here itself, if you see, it is giving us an error. So for that reason, we are creating the function. And in this function, we need a account ID. That is what we'll be updating the new one. But before that, I'll check a condition that if PWD, that is password, or you can give anything, depends on the project. Here I'm just using a dummy. Equal to, let's say the password is mechaniccoder, then only change the mechaniccoder, then only change it to account ID should be changed to whatever you are passing. So account ID equal to ACC ID. Control C, Control flip. So now we have changed it, but how to check it? So even for checking, we need a function void, because this is a private key, right? So void set data. Oh, actually this will be set. This will be set. This should be get, because we are getting the data. So get data, here I'll check only the password. If the password is correct, then I'll display the value. So the same if condition I'm going to put here. So same if condition, Control C, Control V. And the only thing that will be changing here is the work. So here I'll do south. South, what I'll display is my account ID. Control C, Control V. Yeah. So I hope you are clear still here. And now so how you have done your south, right? So the same thing I'll do it here. So for that, I'll say first Swiss dot get data and data requires argument. So let's pass it as mechanic coder. Good. So once that is done, let's change it to capital G. Okay, so once that is done, then we have to call the set data. So let's do this dot set data and let's change it to 1010. And password, we need to pass mechanic coder itself, otherwise it will be wrong because that's what we have given the condition, mechanic coder. And then again, we'll confirm if that has been changed properly. So first get the data, then set the data, again get the data to confirm. And if we check it, so initially it is ABCD, then it is mechanic coder. So here this part is correct. Then here when we get the data, initially it is 1111 because that was priorly set. Then we use the set data and we change it to 1010 mechanic coder. That and then therefore with the help of get data, we are able to display. Here. So I hope we have understood the encapsulation. This will also work on functions, like few functions you can make it, like for example, you shouldn't do for this function, you have to create a separate function, but I'm doing it for this itself. So I can make this function itself private, so no one can access this function. So to access this function, again, I have to set some new function. Okay, so the logic is again same here. Good. So this completes our third pillar. Okay, here we have already discussed about the access modifiers as well as the data heading. For that we had done getter and setter. And here we come at our last pillar of class, that is abstraction. So abstraction can be considered as a blueprint for our class. So it specifies like this function should be there in your class when you implement. Okay, because here if you see interface is again here. Okay, so let's try to do this and check how it works. Okay, so to understand this, let's create an abstract class of bank blueprint. Bank, let's say blueprint. Okay, and this class is having a abstract function, abstract public, abstract, why do we have to write? So it is public abstract. It's not returning anything, void. Let's say registered. Cool. So this is the abstract function. Now, any class which you are extending this bank blueprint, it is mandatory for that class to have this function in it. That is the main purpose of this abstract, we can say, that is providing a structure. So for example, I'll create a new class now. Let's say the class is Union Bank. Okay, and this is extends. What does it extends? Extends bank blueprint. So this extends bank blueprint. So as soon as this extends blank blueprint, then it has to have this function. So let's create a function for that, public void register. Okay, and then we have to do something like so. Yes, register that. Yes, something like we can mention, or any other word you want, you can do. Yeah. So that's the main purpose of abstract. So whenever you have an abstract, that is more like a blueprint. So you can't initialize this. Okay. So if you try to initialize that, for example, if I remove this data, and if you try to create like this, for example, bank blueprint, let's say object one equal to new bank blueprint, then this is going to give us an error. Like if you see, this is not possible. Okay, so you cannot initialize or you cannot create the object of the abstract class because these are like a blueprint. The extended version, that is Union Bank, this is what you have to create an object of. So let's say Union Bank. Then what we have to say is, let's say object one equal to new instance of Union. And if you see now, it will work completely free. Yeah. There is one more error, like if you do not extend it, like for example, if I do Union Bank and if I do it SBI Bank and I do not have this function, then this is going to give me an error because the type SBI Bank must implement the inherited abstract method, that is bank blueprint dot register. So until we implement this, it's going to give us error. So I hope you have understood this, the importance of abstract. That is, it will help us to create the blueprint, and it will make sure that the subclasses will use the exact functions that we have declared. Okay. So I hope we have understood all these four pillars in detail. The last thing I feel which we have skipped is this keyword, that is static. Let's try to understand this keyword static. So any variable or any function, when it is referred as static, so let's say static int num equal to 1, 2, 3. If a keyword is like if a variable or a function is declared like this, then the purpose of this is that whenever you create an object, now object one dot num can't be done because that's a static keyword. Okay, like for example, let me put this in a south statement. South, and here if I do object one dot num, and if you see what it says, the static field Union Bank dot num should be accessed in a static field. Okay, if I run it, clear, it defines 1, 2, 3, but the actual way to get this data is by referring the class name. So this static is referred for what? Union Bank, right? So this object one, instead of object one, you have to mention it as Union Bank dot num, and this is the exact way to call these data. So why it is done in this type? Because like if you say there are multiple objects of Union Bank and you want a variable, like if you change the name of the Union Bank to, let's say, Punjab Bank, then the static keyword should be such a way that it will change for everyone. Okay, once we do project, we'll understand in detail, but I hope like if you have got till here, then that's good. That's enough for today's class. Okay, so yeah, that's it, guys. Let's meet up in next.